Good morning students. Welcome to the next lecture of Electronic Measurements and Instrumentation EMI subject, 4th year 2nd semester. So in this class we are going to see the concept of triggered CRO. In the previous class we have discussed vertical amplifier and time-based generator concepts. In this class we will see the concept of triggered sweep CRO and triggered pulse CRO. These two concepts we will see in this video lecture. So coming to here, this is the block diagram of triggered sweep CRO. In the last class we have seen a sawtooth waveform where the capacitor is charging and discharging periods. Just come back, I will show that things. So in the last class we have seen this sweep or time-based generator concepts. Here we have taken the circuit. Here one UJT transistor is available. R2, R1, RT and CT transistors are available. RT, CT, RT components are timing resistor and timing capacitor. We can call these two combinations. So here, whenever the UJT off position, the capacitor is going to be charged up to Vp. Whenever the capacitor is in the discharging position, otherwise the UJT is in on the condition, then the capacitor is going to be discharged rapidly. At this situation, the particular UJT transistor is on. So first off position of the transistor, then on position of the transistor. Here, now we are going to see in the next concept we will see. In this triggered sweep CRO concept, the same R2 resistor, R2 resistor, R1 resistor, CT capacitor and UJT transistor, we have the common parameters. Other than these parameters, here we are taking one more parameter, diode, and here two more resistors, R3, R4 resistors. We have taken these three components. The first component is diode, second component is R3, the third component is R4. We have taken these three components here with compared to the previous class. So in this concept here, other than the sweep generator circuit, this R3, R4 voltage divider network and this diode here are the extra components. And coming to here, what happened after adding these three components to the circuit? So see here in this waveform, here we have three time periods. The first time period is for capacitor discharging. The capacitor discharging path. In this discharging path, we are representing this value is TR. This is TR is called retrace period. TR is nothing as retrace period. And here the charging period. This is the charging period. This charging period is called TS. That is the sweep period. So wherever the capacitor is going to be charged, that is called sweep period. Wherever the capacitor is discharging, that is a retrace period. And a new one got here. This is TH. A new time period here we are seeing, that is TH, where H stands for hold. So TH is nothing but as hold off period. Hold off period. At this particular situation, the output voltage is constant at VD. The voltage constant at the VD peak value. Okay. So next, see here. This whole time you can keep how much time you require, that much of time you can keep here. That is by giving the triggering input. So see here, this is the triggering pulse and this is the corresponding output. In this triggering pulse, so see here. So this is the max 0 voltage level and this is the negative voltage level. 0 voltage level, negative voltage level. This is completely 0 voltage level. This is a negative voltage level. Whenever the negative voltage is given, then the triggering will be happened here. Here the triggering will be happened here. Whenever the negative triggering is given, the capacitor is going to be discharging position. The capacitor is going to be discharging. The capacitor is going to be discharged. So after the pulse, after this triggering, so whenever the triggering pulse is came to the 0 voltage level, then the capacitor is going to be charged. The capacitor is going to be charged. So after charging this capacitor, the maximum peak value, wherever the VD is, whenever it is reaching to the VD, it will be there. It will be holding there only. After some time, when you are given the triggering pulse, then it is going to be discharging. So this is the behavior. This is the behavior of this triggered sweep CRO. So previously we have seen sweep generator circuit. This is also sweep generator circuit only, but this is the triggered sweep generator. This is a triggered sweep generator. If the capacitor if the UJT is going to be on position, then by giving the triggering pulse, we can make the UJT is on. Right? Whenever the triggering pulse you have given with the negative voltage level, then only this capacitor is going to be discharged. Okay, right. So that is the UJT is going to be on position. Whenever the UJT transistor is on condition, then only the capacitor is going to be discharged. Whenever the UJT is going to be on, the capacitor is going to be discharged. So for making on this UJT, we are giving a triggering pulse. So by giving this triggering pulse, UJT is going to be on and the capacitor is going to be discharged rapidly in this side. In this direction, okay, in this direction it is going to be discharged. So this is the major concepts behind under this topic. Right. Next, see the theoretical explanation for this triggered sweep CRO. The continuous sweep is a limited use of in displaying periodic signal of constant frequency and amplitude. This is very important parameter. Wherever the constant frequency and amplitude we required, at that time this continuous sweep CRO we are using. That means it is actually the UJT in the starting position is off. So off position. At that particular situation, the CT is going to be charging. The CT is going to be charging when UJT is in the off position. Right. The capacitor is going to be charged. After some time it will goes to the peak value VP and it will be there in that position only. Okay, the position will be held for a long time like that only. Whenever you want triggering, then you can give your triggering pulse. So by applying the negative triggering pulse, the capacitor is going to be discharged again and again it will start charging. So that is the cycle repeats. So triggering is given by a user. Right. When attempting to display voice or music signals, the pattern falls in and out of sync as the frequency, amplitude of the music varies, resulting in an unstable display. An unstable display. Whenever the music information, when a music is playing, whenever the voice is coming, then only the display is going to be appear at the total element. So at that particular situation, whenever the triggering will be there, then only it will display the information. Otherwise, it will display nothing information on that area, on that equipment. So for an unstable equipment, finally it results an unstable display. Okay, right. This is for untriggered CROs. So when the untriggered CRO is there, the output is not stable. When the triggered CRO is there, then we can keep the output as stable. A triggered sweep can display such signals and those of short duration, example narrow pulses. A triggered sweep can display such signals and those short duration, that is example narrow pulses. That means the narrow signals this triggered sweep CRO can show, otherwise it can visualize clearly. In triggered mode, the input signal is used to generate substantial pulses that trigger the sweep, thus ensuring the sweep is always that the sweep is always in step with the signal that drives it. So whenever the sweep signal is changing its holding time to discharging period, that is with respect to the triggering pulse. With the sweep output continuously synchronizing with the triggering pulse signal. Right. Next. As shown in figure, the resistance R3 and R4 form a voltage divider network. This R3 and R4. This R3 and R4 is formed as a voltage divider network. R3 and R4 is forming as a voltage divider network such that the voltage VD at the cathode of the diode is below the peak voltage for UJT conduction. Here the voltage VD, so see here, this is the voltage VD. So this is the voltage VD. The voltage VD at the cathode of the diode below the peak voltage VP for the UJT conduction. So whenever the peak voltage is coming, then only the UJT is going to be in the conducted state. Otherwise it will not conduct, it is in the off position. When the circuit is switched on, when the circuit is switched on, the UJT is in the non-conducting state. Whenever you power this circuit, the UJT is in the non-conducting state, that is the off state. And the CT, so the timing capacitor is charges exponentially through RT towards VBB until the diode becomes forward bias. What we discussed in the previous class for the sweep CRO, that is the same, and it will conduct. So after getting the maximum voltage, it is going to be, the UJT is going to be conducted. The capacitor voltage never reaches the peak voltage required for UJT conduction, but it is clamped at VD. So actually it is going to be a full charging situation, the capacitor, the timing capacitor, but it will reaches the maximum VP value, but it will not conduct. It will not conduct. Why? Because the peak voltage is stopped below VD for the diode voltage conduction. So other than that, it cannot conduct. It cannot conduct. Whenever the diode voltage, sufficient voltage you have given, so for the conduction of the UJT, you have to give a separate supply. Then only the UJT is going to be conducted. For that supply, we are giving the triggering pulse. We are giving the triggering pulse. Right? So see here. If now a negative pulse of sufficient amplitude is applied to the base and the peak voltage VP is momentarily lowered, the UJT fires. So whenever the sufficient amount of voltages, whenever the sufficient amount of voltage you have given at the base of this transistor, then only it is going to be fired. Right? Right. As a result, capacitor CT discharges. When it is fired, then the capacitor is going to be discharged in this direction. That is, for making the UJT on, you have to give a negative pulse with sufficient amplitude. CT discharges rapidly through the UJT until maintaining the voltage of the UJT is reached. At this point, UJT switches off and capacitor CT charges towards VBB until it is clamped again at VD. So for every cycle, whenever you are giving the triggering pulse, then only the UJT is going to be from off state to on state. From off state to on state, then only the capacitor is going to be discharging. So this is about triggered sweep CRO. Alright. Next, triggered pulse CRO, triggered pulse circuit. Right? Now, up to now, we have seen we need a triggered pulse. We need a trigger pulse for triggered sweep CRO. So, how this trigger pulse circuit will be available? So, see here, this is a trigger pulse circuit. This is a block diagram of trigger pulse circuit. Here we have vertical amplifier, right? So here this is the input from the channel 1 or channel 2, we are giving the input signal. So that input signal is taken by this vertical amplifier. We have a delay line section here. From the vertical amplifier, this output we are giving to the delay line section, and another line is coming in this direction, and this vertical amplifier is connected to the C1, and this C1 is connected to a special switch called S. A special switch is called S, and this switch has three positions. This switch has three positions. First one is external, second one is internal, and third one is line. Okay, here totally three positions. First position is external, second position is internal, and third position is line. Third position is line, and this switch is connected to a comparator, and this comparator is connected to pulse generator. This comparator is connected to pulse generator. So the pulse generator output, it is nothing but as triggering pulses. Triggering pulses. So see here, external, internal, line voltage. So the internal, so whatever the signal we are connected at the vertical amplifier, that signal is controlling this triggering pulse circuit. That is automatically triggering will be happened based on the input what we have given at the channel 1 or channel 2 side. This is external. External means we are giving manually. Previously, when we are connected the switching to internal position, that is controlled by the signal parameters. When it is the switch is connected to the first position to the external, that is we are controlling the manual, and the second one line. So we are connected this line to the here. So this is the normal AC supply. This AC supply is connected to the comparator. So this triggering will be connected to the line level circuit. So this switch information in the three positions, internal information is connected to the comparator. When it is selected switch S1 into the external position, as second position is connected, the internal is connected to the internal voltages which are coming from vertical amplifier. It is connected to the comparator, and third one, the line voltage is connected to the comparator. These three positions here we have. So after coming this information to the comparator, it will generate either 0 volts or negative volts. It will generate two voltages, negative volts and 0 volts. So whenever the negative voltage will coming from this pulse generator, it will control the sweep circuit of the CRO. So this is the triggering pulse. This is the triggering pulse circuit. So see here the same information what we discussed here up to now. Here the same thing is there. The trigger circuit is activated by the signals of a variety of shapes and amplitude. We can trigger with very different types of shapes and whatever the signal you required, which are converted to trigger pulses to uniform amplitude for the precision and sweep operation. Generally, any type of signal, here we have lot of input signals we are converting all the input signals into the pulse signal. That is with the help of this triggering pulse circuit. If the trigger level is set too low, the trigger generator will not operate. If it has very less voltages, it is not going to be operate. When the triggering level is too high, then the UJT may be connected too long and part of the leading edge of the signal may be lost. So whenever the triggering output level is high, the UJT may conduct for long time and it will operate the circuit. Okay, right. Next, the triggering selection in the three position switch, what we have discussed now, that is internal, external, line, as shown in that figure. The trigger input signal is applied to a voltage comparator whose reference level is set by the trigger level control on the CRO front panel. Okay, so this triggering input we are connecting at the input panel, that is externally the information is coming. The comparator circuit C produces a change in the output voltage whenever the trigger input exceeds the present trigger levels. Whenever the input voltage levels are exceeded, then it will give the different types of outputs. And this is the complete information about jittering and those parameters. The pulse generator that follows the comparator produce negative trigger pulses each time the comparator output crosses its quiescent level, which in turn triggers the sweep generator to start the next sweep. So whenever the negative voltage you have given, then the negative voltage is coming from this comparator. It will triggers the sweep generator circuit, and next sweep will be started from here. The trigger sweep generator contains the stability or sync control. The trigger circuit, it has a stability control and synchronization control. Two types of controls it has, which prevents the display from the jittering. Jittering is one of the problem. The problem it is not, it will come when the synchronization has not done perfectly. Okay, jittering or running on the screen. Stability is secured. Stability is secured by proper adjustments of the sweep speed. So whenever the stability is not whenever the stability is not occurred, then we cannot adjust the speed. So whenever the stability is secured by proper adjustments, we can control the sweep speed also here. Next, sweep speed is adjustable by means of a sweep rate control and its multiplier, that is range control. Here we have a range control knob section is available. With that range control adjustment, we can control the sweep speed. That is, we can adjust the sweep speed. This is very important. We can adjust the sweep speed by using range control. The timing resistance RT is used. The timing resistance RT is used for the sweep rate control, and timing capacitor CT changed the steps for the sweep rate control. So how many times the sweep has to come, that we have to vary with the capacitance of CT, and the RT is used the control totally the sweep rate control. Okay, one is for sweep rate control, the second one steps for sweep rate controls. This is the RT and CT parameters. In the next class, we will discuss the delay line triggered sweep CRO. Right? Okay, thank you.